Hi, this is Mrs. Tellis. We're getting ready to go through adding and subtracting polynomials. We'll also be classifying them, telling what their degree is, and writing them in standard form. Okay, so our first vocabulary word is a monomial. A monomial is a one term. You can see there are some examples here of monomials. Notice they don't have anything connected to them. Okay, a polynomial means many terms. Here are some examples of polynomials. This has two terms, 1, 2. This has three terms, and this is a monomial, one term. This has 1, 2, 3, 4, 5 terms. It's just a polynomial. It doesn't have a special name. Okay. Polynomials that have two terms have a special name of binomial. Just like a bicycle has two wheels, binomial has two terms. And trinomial has three terms, just like a tricycle has three wheels. Okay, standard form is where you write the exponents in order from least, nope, backwards. Write the exponents in order from greatest to least. So all of these examples down at the bottom are in standard form, and you're just looking at the exponent. 2, 1, no exponent. 3, 2, 1, no exponent, and so on and so forth. Okay, the biggest one comes first. The biggest one also tells you what the degree is. So in this example, the degree of the polynomial would be a 3 because that's the highest exponent. Here the degree is 2 because that's the highest exponent. So if I go back to this example, 4 is the degree because that's the highest exponent. Okay, so when we add polynomials, we combine like terms. So I'm going to use a highlighter to show this. You know it's a like term if it has the same variable and the same exponent. So these two are like terms. So I add their coefficients or their front number. So that would just be 8, a to the second. Same thing here. These both have y squared. So when I add those together, that would be 22 y to the second. On the third one, I'd add these two because they have n to the third. That would be, there's a 1 here. So 5n to the third. And the other one would be positive 5 and negative 6. They're also like because they're constants together. So my final answer there. Number 4, you're going to add your like terms. So 6x squared and 2x squared is 8x squared. Then you'll add your x's, so negative 2x and positive 7x, so that's positive 5x. And then the last one I'm going to add are those constants, so that would be positive 9. So again, I'm only adding like terms. Notice that the variables stayed exactly the same, and so did the exponent. I was really just adding and subtracting their coefficients, or the numbers in front, using my calculator to do so. Also notice I put it in standard form. It goes 2, 1, 0 with the exponents. I did the n to the third first on purpose because it has a bigger exponent than the negative 1. All right, so down here, this guy's on his own. I just list him, and he's first because he has the biggest exponent. These two can go together. That would be negative 5a to the second. These two can go together. That would be positive 10a. And then the constants all by itself, I just put it at the back, negative 10. This is my answer. This is my answer. Okay, so I have some more examples here. I'll just go through them real quick. Sum means add or answer to an addition problem. I would add these two, 11x squared, these two, positive 2x, and the back two. And that would be positive 7. Okay, they're getting a little longer, but it's nothing that I can't handle or you can't handle. So x to the third and 3x to the third be 4x to the third. These two would be negative 7x squared, just using my calculator. The x's together would be positive 5x, and plus 9 is my back term. Okay, running out of time, so I think I'm going to head to subtraction. So on subtraction, my 3 steps, first I distribute the subtraction sign to the second polynomial, which means I change all of their signs. And then I just combine like terms like I was doing on the last slide. So you can see in this example, I changed positive 3x squared to negative. I changed negative 2x to positive 2x and positive 12 to negative 12. And then I'm just combining like terms exactly like I was doing last time. So I put the x squareds together, the x's together, and the constants together. And I ended up with this as my answer. Let's do a few. So I'm going to, since it's a subtraction problem, I'm going to find the difference. I'm going to change the second polynomial. I'm going to change all of the signs. And the first polynomial or trinomial is going to stay exactly the same. Notice how I'm rewriting them. So my front one is n to the second. My middle one is minus n or 5n. And my back one is minus 5. So I had to put my n's together. And I also had to put my negative 4 and negative 1 together. So this is my answer. Same thing on the next one. It's a minus problem because it's got a minus between. So I change all the signs in the back parenthesis. The reason that I'm doing that is because I'm actually distributing the negative to all of them. Okay, but I'm really just changing the signs. That's all that I'm actually doing. So if I put my highlights in, these two would go together. The y's would go together, and then the y squared would be on its own. And I'm going to put them in standard form. So the y to the third is first, negative 1y to the third, negative 2y to the second is next because it's got the highest exponent between the green ones and that one. And then the final one is negative 1y. And that's my answer. Those ones are optional. So here I'm going to change all of the signs in the back parenthesis. Change this one to negative, the 2x to negative 2x, and this one to plus 3x. And the front parenthesis stays exactly the same. And I'm just going to gather up my like. So there's squareds that are alike, and there's x's that are alike. And this 3x to the third is on his own. So he goes first because he has the highest exponent. The squareds are next. 1 minus 4 is negative 3x squared. And negative 6 minus 2 is negative 8x. One more. So I'm changing the signs here. And I'm combining like terms. And I'm going to go ahead and do my highlights first. So I'm not switching back and forth so much. So those are highlight. And then his guy, little 10x, he's on his own. He doesn't have anybody to combine with. So I'll start with the highest degree. That's a 2. So that's negative 1x squared. Then the 10x would be next. And then that'd be positive 2 when I stick that in the calculator. Okay, so we've done degrees, we've done standard form, we've classified monomial, binomial, trinomial, polynomial. We've added polynomials and we've subtracted polynomials. I hope this was helpful.